Okay, our bell work problem, it's an ABC problem, so we have to decide if it's simple or complex. Judging by the 2 in the front, the 2 is not the GCF, so that means it's going to be complex. So every complex problem, you multiply the first and the last. Well, basically every ABC problem, you multiply the first one with the last one and you get negative 24. And then you go over to your calculator, go into the table, and you're going to enter negative 24 over x in the first one and negative 24 over x plus x in the second one. Now when we decide which one we're going to pick, we're going to look at that third column and we're just going to look for this 5 right here. I don't care if it's a positive or a negative. Okay, so if I scroll down, you can see that this one right here, the 3 and the negative 8 makes a negative 5. Well, we needed a positive 5, so that just means we have to switch the signs. So instead of positive 3 and negative 8, we're going to be using negative 3 and positive 8. So I'm going to split this up into negative 3a and positive 8a. And then I'm going to drop down the 2a squared and the minus 12. So I've just converted this now into a grouping problem. So I put it in parentheses, 2 groups. I take out the GCF, which is going to be an a here. So I have an a in front, and then I have a 2a minus 3 in here. This one looks like the GCF is going to be a 4. So I can pull out the 4, and this is 2a minus 3. So now I've got my matching 2a minus 3, so I'm going to put 2a minus 3 in the first set of parentheses, and then my original GCFs, they create the second set of parentheses, and then that's my answer. So what we're going to get into today is difference of squares. So first, how to recognize it. It has to be a binomial. So a binomial means it has to have 2 terms. It has to have a subtraction sign in the middle because it's a difference. In math, difference means subtract. And then both terms have to be perfect squares. Now you can test if something is a perfect square by taking the square root of it. If it has an answer that's not a decimal, well then that's a perfect square. This right here, this is your formula for the difference of squares. And if you notice, the factors, they look exactly the same except one's a plus and one's a minus. So if there was a way to just come up with one set of parentheses, then we could just make a second copy and change the sign. So this is how it's going to work. If I could just come up with a way to come up with that first parentheses, the second set will be a copy. So all I have to do is take the square root of x squared, so that gives me an x. Then I'm going to take the square root of 25. Don't include the negative in there. So that's, let's see, if I go into my calculator, into the regular mode, I can take the square root of 25 by hitting shift x squared, and I hit the 25, and the answer is 5. So I stick a 5 in here. Now according to the pattern, if I have an x and a 5 there, I'm going to have an x and a 5 here. Because if the first one is A, the first one over here is A, and if the second one is a B, the second one over here is a B. So they have to match. Then I just have to put 1 plus and 1 minus and I'm done. That's the answer. So these ones are pretty straightforward. Create the first set by taking the square root of each term. So this is P and 6. Make a copy and then put a plus and a minus. So if I take this one's going to be 3 and x together, and then a 1 here. So that means this is going to be a 3x and a 1 again, and then one's a plus and one's a minus. And it doesn't matter what order you put the plus and minus, as long as one has a plus and one has a minus, and the stuff is the same, you'll get the correct answer. So if I square root this, that's going to give me a 2n. Square root that one, I'm going to do a 7 there. So that means the second one is also going to be 2n and 7. One's a plus, one's a minus. Okay, so that's difference of squares. Now we're going to move on to sum and difference of cubes. So just like the last one, it has to have 2 terms. Now the thing that's different about this is it could be a plus or a minus. It doesn't really matter, but it is going to have to be a perfect cube. A perfect cube, a lot of times it's going to have a x cubed or something like that. But if you want to see if it's a perfect cube, you can always cube root it. Now there's a formula for this. There's actually 2 formulas, but I'm only going to show you one. And again, it's based off of this first set of parentheses. You can create this other set just based off of the first set of parentheses. So if there's a way to come up with the first set, we can create the second set after. Now there's also an acronym for the signs. When we fill in the signs, we use S, O, AP. SOAP. S stands for same as the original problem, always going to be the opposite, and then AP stands for always positive. So here's how this works. In order to come up with our answer, all we're going to have to do is come up with the first set, and then we're going to use that to build the second set. So if I cube root this, that just gives me an x. If I cube root this, I can go over to my calculator. The cube root button, there's two of them actually. You're going to hit shift and the open parentheses, and then I can put in my 125. So that gives me a 5 again. Now I mentioned that there's two buttons you can use. You can actually also use the shift and the caret key, which is right next door to the x squared button, and then you can just manually put in the 3 and then put in your 125, and it'll give you the same exact answer if you can type right. 225. So it's still a 5. Okay, so here's how the pattern works. You're going to use, if this is A and this is B, the pattern is A times A times B, and then B times B. So x times x would give you x squared, x times 5 would give you 5x, and then 5 times 5 would give you 25. Then you use the SOAP acronym to fill in the signs. Same, opposite, always positive. I'll show you that a few more times because this is actually pretty quick. You come up with the first set by cube rooting. So we're going to cube root each term. This is going to give me an x and a 4. If this right here is my A and this is my B, the pattern is A times A times B, and B times B. So x times x would give me x squared, x times 4 would give me 4x, and then 4 times 4 would give me 16. Then we use the SOAP acronym, so it's the same as the original problem, opposite, always positive. Okay, next one, cube root. So cube root of 64 is going to be 4, cube root of x squared is x, and then the cube root of 1 is just 1. So we're going to use that to build our second set of parentheses. Pattern is A and B here, A times A times B, B times B. 4x times 4x is 16x squared. 4x times 1 is 4x. 1 times 1 is 1. Then we use the SOAP acronym. Same as the original, opposite, always positive. Okay, last one. Cube root. Cube root. So let's see what we get here. We're going to get a 2x and we're going to get a 3y. Notice I don't put any signs. I save the signs for the end. So now I got my big set of parentheses, and this is A and B. So this would be A times A times B, and then B times B. So 2x times 2x is 4x squared. 2x times 3y would be 6xy. And then 3y times 3y would be 9y squared. Then we have to go do the signs using the SOAP acronym. So it's same as the original, opposite, and always positive. So that's pretty much it. That's the special binomial. So you have the difference of squares. That one looks the same, but opposite signs, and you just square root them to get the first parentheses. And then you got the cubes. And in that one, you would just have to cube root to come up with the first parentheses. Second parentheses is A times A times B, and then B times B. Good stuff.